All right, so this video talks about we're solving quadratics. If we're taking a look here, let's say I have like 4x squared minus 9 equals 0. Okay, should be triple equal, sorry. So equals 0. All right, so 4x squared minus 9 equals 0. And in this equation, normally we do our normal checks of different things that we can look for. So if it's an equation, quadratic, I want to make sure it's equal to 0, which it is. First thing I like to check for is for a GCF, meaning is there a factor out of 4 and 9 I could pull out of both. Unfortunately, I can't. Okay, the next thing I like to check for is called the PST, also known as a perfect square trinomial. But it's only a binomial, right? 4x squared minus 9 is a binomial, so I can't do that. Third thing I would always like to check for is if I could factor, so just generic factoring with the x, so x factor is what I call it. And again, it's binomial, I can't do that. So there was a fourth method that we discussed in class, or if you've never had me before, it's called difference of two squares, or dots. Okay, so difference, okay, so subtraction, cool. All right, then two squares. So 4 is a perfect square and 9 is a perfect square. All right, and x squared is a perfect square. So this one would work for the difference of two squares. So what I could do, if we remember the shortcut, we take the square root of the first term, square root of the second term, so 2, x, and then 3 and 3. And the way to get negative 9 is one is positive, the other one's negative. Okay, and that's how we begin to solve this one. Okay? But let's say, so this was a poor example, but this list here is a good list to go through. Okay? So GCF took care of that. PST, it's not a trinomial, so I couldn't do that. Again, X factor, it's not a trinomial, so I couldn't do that. So difference of two squares, I could do because it happened to work out. So let's say I did another problem. Let's say it was really close. Let's say it was 4x squared minus 10 equals 0. Okay? So I couldn't do any of those things. So if factoring doesn't work and difference of squares doesn't work, you should check to see, so I call it step 5. So if it's a binomial, then just solve from here. Because here's the cool thing. Because there's no middle term or b, right? There's just the x squared term and then the constant. What you can do at this point is actually just get x by itself right now using our traditional algebra. 4x squared equals 10, and then divide by 4. X squared equals 10 over 4. Okay. Then, how do we get rid of a square? The opposite of a square is a square root, or a second root. So if we do that, this is going to be x equals square root of 10 over 4, which, remember, could I write the square root of 10 over the square root of 4? I can, which would give me square root of 10, which is not a perfect square, but square root of 4 equals 2. Okay. So, if it's a binomial, we solve. And then if it's not a binomial, so kind of like step 6 here, or 5b. So if not, there are a couple other methods that we're going to discuss here. But this is how we would solve if it was just a binomial. And again, I couldn't take out a GCF, and I couldn't do perfect square trinomial, can't do factoring, difference of two squares. We can solve it straight up from here and find out what x equals. So, just like our traditional algebra, you get x by itself, move the other term to the right side, and that's how we do it. So, here's another example. Let me give you another one here. Let's do 3x squared plus 2 equals 77. Okay, so 3x squared plus 2 equals 77. All right, so again, I'm going to make sure it's set equal to 0, because I always like making sure the equation is set equal to 0, because it's quadratic. I know it's quadratic because of the square right there. Okay, so 3x squared, it'd be minus 75 equals 0. Okay, so again, it's a binomial. So GCF, well, actually, I can pull out a GCF. I can pull out a 3, which seems to be that x squared minus 25 equals 0. Okay. So I can pull out a 3. That's fine. Perfect square trinomial. Well, it's not a trinomial. I can't do that. X factor. Again, it's not a trinomial. I can't do that. I mean, technically, you could do this. So x squared plus 0x minus 25. You can make it a trinomial if you'd like. But there's other methods that we can use. So if I told you you have to factor, you could do that. Okay. You could do that. Then there's dots, difference of two squares, which actually x squared and 25 are perfect squares. But let's say you didn't recognize that. Let's say you didn't know that. Okay, we're going to move this 3 out to the side here and not forget about it till later. So what if I had x squared minus 25 equals 0? You can solve that right now by adding 25 to both sides. And x squared equals 25. And we take the square root of x squared, because that's how we cancel it out. Those cancel, x equals. And of course, when I take the square root, that's something I didn't do on the previous problem. Let me go back. When I take the square root, I have to put plus minus. Whenever I put the square root inside of a problem, you have to put plus minus. So plus or minus, the square root of 25 is 5. So x equals plus or minus 5 would be my answer. Okay? So that is how you deal with a binomial after setting it equal to 0. You can solve it immediately, or you can use a, again, we could have done, right, because both of those are perfect squares, we could have done 3 and then done x, because the square root of x squared is x, square root of 25 is 5. We could have done x plus 5, x minus 5. So, and then there's another technique from here we would learn, but that's solving with factors, and we'll get into that later. But anyway, this is how you solve with square roots. It has to be a binomial, and when you figure out it's a binomial, you could just move the constant or just the number to the right side, keep the variable on the left, divide, and work with that. So there you go.